Hello everyone, today I'm going to show you how you can integrate mods. It's another useless but interesting thing. So first, the mod function, as you can see up here, is just the remainder function. So if you have mod of x, x mod 4, which is how you write that in Desmos here, you can see that the remainder just gives you these bars because as x increases, the remainder is always going to be the same. Now the interesting thing is when you take the remainder of 4 with mod of x. Here you can see there are infinite many lines down here. And this is because whenever you have 4 over any natural number, that's always going to yield an integer when you divide that by 4. And I'm going to show you how you can integrate this. So this is all the sum of all these lines. And for all the integrals, no matter what the 4 is over here, or the coefficient of x, I always move it from 0 to the point where the mod just finishes before it's a straight line, because from there on it's useless and the rest you can just calculate by yourself. So here is this, dx. Now this is going to be the sum from n equals 1 to infinity of all the integrals of these lines. And as you can see here, this is actually just the gradient of this, right? If you increase n, it's always going to be the same gradient and same y-intercept. So that's going to be this. Now we just integrate this normally. Let me expand this out. Ignore the plus c, I know, but like, can't be bothered to do that. Then you get this once you factor it out. After doing a bit of algebra, you get 8 times this fraction over here. Now using partial fractions, you get these 3 sums. And these 3 infinite sums are pretty self-explanatory. 1 over n minus 1 over n plus 1. That's just 1 because they telescope and they cancel each other out. And 1 over n plus 1 squared, that's just the basal problem, right? But shifted ahead 1 term. So this is going to be pi squared over 6 minus 1, because it's ignoring the first term. And remember, the negative of this, so it becomes 8 times 2 times pi squared over 6. And you'll have to take my word for it. I'll show you how we can prove this for the generic case later on. So now, if you want to do this for the general thing, where you have mod of mu mod mx, here you can see the gradient is going to be just mu minus mnx, and here I can play with these two. As you can see, this is always going to be the gradient. This is how you just make your infinite sum. So integral from 0 to mu over m, again, as you can probably guess, when you increase the coefficient of x, that just scales the thing backwards. So that is why I keep on making it smaller. So yeah, as you can see, as m increases, it just gets shorter and shorter. That's always going to be at mu over m. Okay, so same idea. You integrate this. You know that this is the same thing. You here just do a bit more algebra, but you can just factor out mu squared over 2m. And then you get this triple fraction, which actually just adds up to this over here. I'm not going to show that, but you guys can do the algebra if you want. And this we know, because it's the same thing, is just 2 minus pi squared over 6 times mu squared over 2m. So let me show you here. So here I have Desmos manually computing the integral, and here I have my formula, which should work. So as you can see, even as I just change mu and m, even into the negatives, it still works. It's actually really interesting. A lot of fun actually finding this formula. And yeah, I hope if you ever need to integrate a mod, that you actually first comment on this video and tell me how you use it. And second, that you enjoy using this formula. Thank you very much.